Hello students, this is Latif sir. Today I am going to discuss about general uses of some bases and test for acidity and alkalinity. So let's start. First, general uses of some bases. In the box, some bases, example of some bases given and their use also given. Okay, so let's see sodium hydroxide, which is used in the manufacture of soap. Potassium hydroxide used in manufacture of salt and soaps and used in batteries. Third, calcium hydroxide, which is also known as slaked lime. Slaked lime used in the manufacture of bleaching powder and softening of hard water. Magnesium hydroxide is used as antacid, that neutralizes the excess acidity in our body. And aluminum hydroxide used as a foaming agent in fire extinguisher. And ammonium hydroxide is used to remove grease stains from clothes. Magnesia, that is magnesium oxide, which is also a basic base, and it is used in making refractory bricks. And calcium oxide is used as drying agent and basic flux. So these are common bases and their uses. Okay, now test for acidity and alkalinity. How to identify whether a solution is acidic in nature or neutral or basic in nature. The acidity or acidic, basic or neutral, the acidic, basic or neutral solution can be tested by using some common indicator. For example, litmus paper, methyl orange, phenolphthalein. These are common indicator. By using this indicator, you can test uh, whether a solution acidic in nature or basic in nature or neutral in nature. Okay, and you know that on ionization of water, water is very poor. The extent of ionization in water, pure water, is very low. Okay, that is water ionizes to a very small extent, and on ionization of pure water, it produces H3O plus ion and OH minus ion, that is hydronium ion and hydroxyl ion. And the concentration of H3O plus ion, hydronium ion and OH minus ion in water, pure water, are same, and the value of concentration of H3O plus ion and OH minus ions in case of pure water is 1 into 10 to the power minus 7 mole per liter. Okay, so 1 into 10 to the power minus 7 mole per liter is the concentration of both H3O plus ion and OH minus ion. Okay, so what is the multiplication of concentration of H3O plus ion and OH minus ion in pure water? So the value of multiplication of H3O concentration of H3O plus ion and OH minus ion is equal to 1 into 10 to the minus 7 into 1 into 10 to the minus 7, that is 1 into 10 to the minus 14 mole square liter inverse 2. So 1 into 10 to the minus 14 is the multiplication of concentration of H3O plus ion and OH minus ion in pure water. Okay, and this is known as ionic product of water, which is represented as Kw. That is Kw is equal to 10 to the Kw is equal to concentration of H3O plus ion into concentration of OH minus ion within third bracket, means concentration. Okay, within third bracket H3O plus means concentration of H3O plus, and within third bracket OH minus means concentration of OH minus ion. So Kw is equal to within third bracket H3O plus ion into within third bracket OH minus ion, and the value of Kw at 25 degree Celsius is 1 into 10 to the minus 14, and this is known as ionic product of water. Okay. Now nature of a solution, I have told in previous videos that all acid produces H3O plus ion, and bases produces OH minus ion, but water can produce both ions, H3O plus ion and OH minus ion. In case of aqueous solution of acids, you will get concentration of H3O plus ion is more, and in case of basic solution of aqueous solution of some bases, you will see that concentration of OH minus ion is higher and concentration of H3O plus ion is lower. Okay, so the nature of solution depends upon the concentration of H3O plus ion in solution. In case of acidic solution, concentration of H3O plus ion is more. In case of basic solution, is concentration of H3O plus ion is less. Okay, a Danish biochemist Sorensen, who devised a scale which is known as pH scale. Okay, by using this pH scale, you can calculate. You can calculate, or you can say whether a solution is acidic or a basic solution. So biochemist Sorensen devised a scale known as pH scale, which represent the H3O plus ion concentration of the given aqueous solution. In pH scale, the P in pH stands for potenge. In German word, the potenge means power. Okay, so pH means power of hydrogen, and mathematically pH means pH of a solution is the negative logarithm logarithm to the base 10. Is the pH is the negative logarithm to the base 10 of the hydrogen ion concentration expressed in mole per liter. Concentration of hydrogen ion, that is H3O plus ion. Concentration of hydrogen ion means concentration of H3O plus ion, measured in or expressed in mole per liter unit. Okay, so pH is equal to log 10 base 1 by concentration of H plus ion, that is 1 by within third bracket H plus, or you can also write pH is equal to minus log 10 base concentration of H plus. Okay, so pH is equal to minus negative logarithm, that is minus log 10 negative logarithm to the base 10 of the hydrogen ion concentration, that is pH is equal to minus log 10 base concentration of H plus, and concentration of H plus in the solution is expressed in mole per liter. Suppose concentration of H plus ion in a solution is 10 to the minus 12. Then using this equation, pH is equal to minus log 10 10 base concentration of H plus. Using this equation, if the concentration of H plus ion in the solution is 10 to the minus 12 mole per liter, then the pH becomes, pH is equal to, by using this formula, if you calculate the pH of this solution having concentration of H plus ion 10 to the minus 12 mole per liter, you will see that pH is equal to 12. If concentration is 10 to the minus 6, then pH is 6. If concentration is 10 to the minus 8, then pH is 8. Okay, just it is a simple mathematical expression. And this is pH scale. You can see in figure 3.1. In pH scale, there are total 14 marks. Okay, 0 to 14. The normal pH scale ranges from 0 to 14 as given in the figure 3.1. And the value value of pH 7, which indicates neutral solution. If pH value is 7, then the solution is known as neutral solution. If pH of a solution is less than 7, then the solution is in acidic nature. If the pH of a solution is greater than 7, that is 7, 8, 9, 10, 11, 12, 13, 14. If the pH of a solution is greater than 7, then the solution is basic in nature or alkaline in nature. Higher the value of pH, higher the basic nature of the solution, and lower the value of pH near to 0, higher is the acidic strength or acidic nature of the solution. Okay. In a colorless liquid, if you add a universal indicator, you can say by this using this universal indicator into a colorless liquid, you can say about the acidic or basic nature of the solution. Okay, so universal indicator is one type of indicator which shows color change in shows defined color change in different medium. The universal indicator is a mixture of indicator. Universal indicator is a mixture of indicator dyes that gives a spectrum of colors, that is different color, depending on how acidic or alkaline a solution. Universal indicator give different color at different concentration of hydrogen ion in a solution. For example, a universal indicator produces green color in a neutral solution. If a solution color of a solution become green, if a color of the solution become green, or color of universal indicator become green, then the solution is neutral in nature. Okay. Similarly, for basic solution, color change of the indicator, universal indicator, uh, color changes from blue to indigo to violet as pH increases progressively. Then in case of basic solution, the color change, you will see the color change from blue to indigo to violet as pH increases from 7 to 14. Similarly, the color change in acidic solution is from yellow to pink and then red as the pH progressively decreased from 7 to 1. Okay, if pH decrease from 7 to 1 progressively, you will see the color change of the acidic solution from yellow to pink to red. Okay, and this is universal indicator. Here in this universal indicator, pH value and color at that particular pH also written. You have to see. So this is a color change of a universal indicator in the in different acidic or basic solution. By using this universal indicator, you can identify whether a solution is acidic or basic, or how much acidic or how much basic in nature or alkaline in nature. Okay, and universal indicator shows different color in different basic or acidic medium. I have told in. Okay, now importance of pH in everyday life. There are many importance of pH in our daily life, in digestion of food, in agriculture, in medicine. So let's see the importance of pH in everyday life. Our body works within the narrow pH range of 7 to 7.8. 7 to 7.8 means basic in medium, basic in nature. So our body work in a slightly basic in nature, basic medium. Okay. Similarly, plant and animal also survive in in a narrow range. Second point, in agriculture, every crop every crop grows better in a particular pH range. For example, rice grows better in slightly acidic soil, sugarcane in neutral soil, and citrus fruits in alkaline soil. So in agriculture, pH has important role because different crop grows in different medium, different soil, different types of soil, acidic, some plant or some crop grows in acidic soil, some in neutral soil, and some in alkaline soil. Third, third importance of pH in everyday life is if the pH of of a rain is become less than 5.6, then the rainwater is said to be acidic in nature, that is acid rain. Okay, if the pH is less than 5.6 of rainwater, then it is said to be acid rain, and acid rain contains different acids like sulfuric acid, nitric acid, carbonic acid, and these acids are produced when rainwater reacts with some gases present in atmosphere. Present in atmosphere. Huh. Which gases? Sulfur dioxide, oxide of nitrogen. Okay. So this acid rain have many bad effect to soil, to marine life. Okay, so acid rain reduces fertility of soil. Acid rain destroys marine life and causes damage to monuments. These are bad effects of acid rain. And acid rain is pH of acid rain is less than 5.6. You have studied in class 9 last chapter. And next important is in medicine, certain diseases are diagnosed only on the basis of the pH value of blood and urine. Next important is in digestive system. In our body system, hydrochloric acid produced in stomach, which helps in the digestion of food. But if hydrochloric acid produced in excess amount, then mm, will fall, then we will observe many problem, huh, like pain or irritation, like this. So excess of hydrochloric acid, that is pH uh, pH of the solution in our body system will become less than 7, that is pH falls. And we know that in our body system works slightly basic in medium. Okay, but when excess hydrochloric acid produced in our stomach, the pH falls. That's why we feel pain, irritation. Okay, and to solve this type of problem, you have to take antacid, because excess acid produced in our body system, to neutralize this excess acid, you have to take antacid like milk of magnesia. Okay, and next is in the prevention of tooth decay. When pH of our in our mouth falls to 5.5, pH falls to 5.5 tooth decay start. And tooth enamel, which is actually calcium phosphate, is the hardest substance in our body, and it gets corroded when pH falls falls to 5.5. Okay. And next is bee sting leaves acid in the body. If baking soda, which is a base, is applied on the stung area, it gives relief. And these are the importance of pH in everyday life. Okay.